Hello, welcome back to my channel. Today we'll be doing mathematics and I'll be looking at ratios of special angles. So these special angles we'll be considering would be angles 45 degrees, 30 degrees and 60 degrees. So apart from the tables and sine, cos and tan tables, these angles, their ratios can be derived using the right angled triangle. So let's assume you're given an isosceles right angled triangle with sides having 1 unit. Okay, so by isosceles I mean that two of the sides will be equal. So if you have, let's say this is your right angled triangle isosceles, you have A, B, C with this side 1 degree, 1 unit, so makes these two sides equal. So if we have 45 degrees here, we are looking for ratios of 45 degrees. It means this side is the opposite and we are looking for the hypotenuse. So knowing that, we're going to use the Pythagorean theorem. Pythagorean theorem, and by Pythagoras theorem, say this is x, this is y, and this is z, which means x plus x squared plus y squared will be equal to z squared. Okay, therefore we're going to have our x1 squared plus y squared will be plus 1 squared, because y also is 1, will be equal to z squared. 1 squared is 1 plus another 1 squared, 1, to give us z squared. 1 plus 1 is equal to 2. 2 is equal to z squared, but we are not looking for z squared, we are looking for z. So we come this way and continue. So if we say 2 equal to z squared, we look for square roots of both sides, and square roots cancel squared, cancel square, so we are left with z to be the square root of 2, and that's it. Z is the square root of 2. Therefore, okay, so we come back here, we have square root of 2. So don't forget, sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. So we're going to make use of this to find the ratios of 45 degrees. So if we have sine, okay, I'm going to manage the given space, the available space. So if we have sine 45 degrees, is going to be equal to, this is degree, sine 45 will give us opposite over hypotenuse. If this is 45 degrees, which means here would be the opposite, and since opposite would be 1 over hypotenuse would be, our hypotenuse is the longest side, so it will be square root of 2. So our sine 45 will be square root, it will be equal to 1 over square root of 2. If you have your calculator closed, you can just punch that, and whatever result you get, if you check it on the tables, it will be the same thing. So that's it. The next cos 45 degrees will be equal to, if you check here, cos theta adjacent over hypotenuse. On this, if this is the opposite, therefore this would be adjacent. So adjacent would be 1 over hypotenuse square root of 2 also. Okay, so tan theta would be equal to, tan theta is opposite over adjacent. So since this is opposite and this is adjacent, tan theta will be equal to 1 over 1, which is equal to 1. So sorry, tan 45, not tan theta this time around, tan 45 degrees. We are now considering the degree. So that is for 45 degrees. We are done. Tan sine 45 degrees, 1 over square root of 2. If you punch this in your calculator, whatever figure you get, and you check your table, you're going to have the same thing. And cos 45 degrees will be 1 over square root of 2 also. So sine 45 degrees and cos 45 degrees would be the same result. Then tan theta will be 1, and if you check that on your tables, you should get the same value. So that's for 45 degrees. And let's check out for the next one, which is 30 degrees and 60 degrees. They are not the only ones that can be considered using the right angle triangle, but they are just the ones I'll be picking for this video. Maybe some other time, or consequently when I'm done with these ones, I'll pick 90, 180 also. But for now, I'm treating just these 3. Okay, so we're done with 45 degrees. So we are now trying to deal with 30 degrees. Now say we're given a triangle, an equilateral triangle with sides 2 units, and equilateral triangle has all sides equal. Therefore, which means if we have 2 units here, we are going to have 2 units here, and we'll have 2 units here. So that makes all sides equal. And since we're going to have 180 degrees in a triangle, so we're going to have 60 degrees here, 60 degrees and 60 degrees. So assume now we divide this triangle into 2 equal parts. Okay, so remember we have 60 degrees here, so if it's divided, we have 30 degrees up here. And now if we divide 2 units by 2, we have 1 here, 1 here, and we can sketch that out here. We are going to get a right angled triangle, just like this. Okay, so we are going to have 2 here, 1 here. We have 90 degrees, and we have 60 degrees here, and we would have 30 degrees here because we've already divided it by 2. Okay. All right, so that's it. What I've just taken is this side of the this part of the right angle triangle. Okay, so this 2 is supposed to be here. Well, we are going to try to look for this side, not 2, because this is the line we broke the triangle. All right, so